In this video, I will explain a solving strategy that can be used for converting Lewis structures or structural formulas into bond line structures. According to this solving strategy, step 1 should be choosing the main chain. And by the main chain, I mean just choosing a chain of carbon atoms or a chain of atoms that are bonded together, and usually this is the straight chain. Second step is replacing each carbon by a dot, whereas keeping oxygen or nitrogen or sulfur as they are. For example, in this case here, we have 3 carbons, so we will draw 3 dots, and those dots should be drawn in a zigzag form. The second step or third step will be connecting these dots. So I will connect these dots by single bonds. And then once you're done, just compare your structure with the Lewis structure. And if you have to add a double bond or a triple bond or a bromine or oxygen or a branch, just do that. In this case, we don't have to add anything. Let's move on to the second example. Again, this is my main chain, which consists of 3 carbons and a chlorine. So 3 carbons means 3 dots. Chlorine should stay as it is. So again, connect them by single bonds, and we're done with the first 3 steps. Now, since we have a double bond between carbon number 1 and carbon number 2, I will put a double bond between carbon number 1 and carbon number 2. Of course, it doesn't really matter if you draw this bond from the top side or the bottom side. And we're done. There are no more branches or no more extra bonds that should be added. Now, with respect to the lone pairs, you can draw them and you can skip them, but you have to know that these usually exist here. Let's move on to the second example, now third example. Again, we have 3 carbons, so 3 dots in a zigzag way, connect them by single bonds. And we don't have a double bond or triple bond, but we have an OH group just above carbon number 2. So I will put an OH here and then connect it to this one. And this is how we draw the Lewis structure, the bond line structure of starting from Lewis structure. Let's try to do these examples now. Again, choose the main chain. This should be the main chain. Of course, it doesn't contain the hydrogen. So I have 3 carbons and an oxygen or an OH. So I have 1, 2, 3, and an OH. Again, connect them by single bonds. We have a double bond between carbon number 1 and carbon number 2, so the double bond will go here. We have 1 carbon below number 2, so this 1 carbon will be replaced by a dot, and then connect this dot to the main chain. And we have a double bond O here at carbon number 3, so the double bond O goes here, and this is the structure. Now, someone could have drawn the zigzag form in this way. And when it's time to add this branch, which is here, if you put this carbon here, it will go down, which is fine, but the structure is not really nice, because usually when we draw bond line structures, we prefer that if the zigzag is going up, then your branch should be going up. If the zigzag is going down, then it is preferred to draw the bond down. Although it's not wrong, but it doesn't really look nice. Same thing applies for this double bond O. So this is okay, but this is actually better. So let's try to do this example right now. Again, we have 3 carbons and a nitrogen, so 3 dots and a nitrogen and H2, because we have 2 H's at this nitrogen. Connect them by single bonds. Now they are connected. We have a double bond between carbon number 1 and carbon number 2, and above carbon number 3 we have 2 carbons, so we have 2 dots. So this is carbon number 3. We have 2 dots here. Just connect those dots to the main chain, and this is the structure. Again, if you draw those 2 dots or 2 branches to the at the bottom side, again, this is also, both are correct. Let's do the last one here. This is my main chain, which has 4 carbons. So I have 4 dots, zigzag form. We have a triple bond between 1 and 2, so we have to put a triple bond. This is usually how we draw a triple bond. And then above carbon number 3, which is this one, we have 1 carbon, so 1 dot here connected to the main chain. And we have 1 carbon below, again 1 more dot, put it here. And then we have bond OH, so bond OH. And this is the structure of the compound. Now, you will learn this later on, that whenever we have a carbon with a triple bond, then the bond angle will be 180 degrees. And that's why we prefer to draw triple bonds in a linear form rather than in this bent form. Although, again, this is not incorrect for now. So this is the bond line structure of this compound. In the next video, I will show you a solving strategy that can be used for converting bond line structures into structural formulas, or sometimes what we refer to as a reading bond line structure. So by just looking at the bond line structure, you will know how many carbons do we have and how many hydrogens do we have in each at each carbon.